right, we are in semester 2 of Foundations of Algebra. So we are starting with section 4-1, real numbers. And this just kind of explains the number system and gives you some definitions that you're going to need to know and understand. So set notation is just using these little bracket kind of guys. They're kind of like parentheses, but not. Yours will probably look much better than mine. They're just a little bracket, and all it does is represents a set of numbers. And you'll see what we mean in a minute. Set of numbers. Okay, so let's talk about some different numbers here. So way back when the cavemen are counting, how many pterodactyls they've hunted that day, then they had natural numbers. You count, how many rocks do we have? 1 rock, 2 rocks, 3 rocks. So natural numbers were just the original numbers that they could count. So 1, 2, 3, and on and on and on. Okay. But then they said, well, wait a minute. What if we have no rocks? So all that is, the whole numbers are just those same positive numbers, but with 0 thrown in. That's all they are. Because what if you don't have any rocks? And you have to be able to account for that somehow, right? So it's just the natural numbers plus 0. Okay? So, but then we get into, well, now what if back when they're counting and they need to count birds that they hunted and they need to give somebody else one of their birds. So now you don't have that bird, somebody else does. So that involves a negative number, something you're giving away. So integers represent all the negative numbers, 0, and all the positive numbers. So you would start way down at negative infinity, which we'll talk about in class, and then say you would have -3, -2, -1, 0, 1, 2, 3, on up to infinity. Okay? Then, rational numbers. Well, what are the first 5 letters of that word? And that's ratio. We already know ratio is a fraction, because we've been working with those a lot. So a rational number is just a partial number, and it can be written as a fraction. Simple. Okay. Irrational numbers, on the other hand, just the opposite. They cannot be expressed as a fraction. Okay? So we talk about the differences. So when you have these fractions, they either need to be a terminating, able to be rewritten as a terminating decimal or a repeating decimal. And we'll see what that looks like in a minute. Okay? All right, so rational numbers. So let's leave the negative off for a minute. But if I go ahead, and we know that any fraction can be changed into a decimal, then, because we know that that line in a fraction means divide. So let's divide 1 divided by 8. We've already done converting fractions to decimal. That's a terminating decimal. It's equal to 0.125. So this is definitely a rational number, okay, because that's a terminating decimal. It has an ending point. Let's try 16 divided by 11. Okay, so there you've got 1.454545. So that is what we call a repeating decimal. So that's 1.4545, and on. That never stops. So the way we would write that is 1.45 with that bar over the top. So this is terminating, just so you understand the difference. It's ending. Terminate means end, right? And this is a repeating decimal. So either of those will show you that you have a rational number. Okay, let's look at irrational numbers. Well, now you've got square root in there. So let's flip the calculator around and let's do square root of 2. And it definitely has a value, because it means what number can I multiply by itself to get 2. So it's definitely got a value, but there is nothing repeating or terminating about that. So that is an irrational number. And not all square roots are going to be irrational, but it's something that you need to be aware of. Okay. And an easy way to check that is on a calculator. The other one we have, of course, is pi. And we have a value for pi, right? Which is 3.1415926. And I can't memorize all the numbers. You know it is 3.14. That's what we rounded off to. But it definitely has thousands of digits. It never ends. 2, 6, 5. So those are non-terminating and non-repeating. So that's what makes them irrational. Think about they're not predictable, right? If somebody's a rational person, you can pretty much predict their behavior. You can predict the behavior of a rational number. You cannot predict the behavior or the numbers that are going to come to the right of the decimal in a rational number, okay? All right, so let's look at these numbers down below and see if we can classify what they are. So 5, well, we know that's a whole number. We also know it's an integer, because that's just all the natural numbers plus 0, all the positive and negative numbers. It's definitely rational because it can be written as 5/1. Oops, sorry, let me move up a little bit. It's not irrational. Okay, so we can write this as 5/1. 0.6 is 6/10, so it's not a whole number. So let's cross out what they aren't. It's not a whole number, we know that. It's also not an integer, but it is rational. Okay. And it's not irrational because we can write that as a fraction. Okay, so negative 24 is not a whole number because it's negative. However, it is an integer, and any integer is automatically rational as well because we can write them all as a fraction, right? So, 9/7, well, let's cross out the ones they're not, is not a whole number. We know that. It's not an integer. It is rational, and it is not irrational. Okay, let's try square root of 11. So if you can quickly tell me off the top of your head let's think about square roots. So let's think about square roots that are really close to that, right? And I know we haven't done square roots yet, but I know you've done them before. So what number multiplied by itself equals 9? And that would equal 3. What number multiplied by itself gives you 16? That would be 4. So square root of 11 is somewhere in here, but we don't know where it is. It's somewhere between 3 and 4, but we have no idea what that number is just off the top of our head. So it's definitely an irrational number. We can't write that as a fraction. It's definitely not an integer and not a whole number. Okay, 2.823 with the 2, 3 repeating. We know it's not a whole number, not an integer, but it is rational because it's a repeating decimal. And then 2 2/3, definitely rational because it's fraction. Not a whole number, not an integer, and not irrational. Okay, good. All right, and you should be experts at converting mixed numbers into fractions at this point. Now the only difference here is you have a positive and a negative, but that's okay. We know we multiply the denominator by the whole number and then add the numerator. So in this case, 2 times 3 is 6 plus 2 would be 8/3. Same thing here. Now we know that the number is going to be negative, so just put your negative down and then you're done with it. 3 times 5 is 15, plus 4 is 19, so it's negative 19/5. Good. Okay, absolute value. So this is something that can get sort of confusing, but it's actually really simple. Absolute value is just the distance between a number and 0. That's all it is. How many steps do you have to take to get there? A number and 0. Okay, so if you think about it on a number line, now a lot of number lines you guys have seen are horizontal number lines. I actually really prefer vertical number lines, so I'm going to draw one here. I think it makes the positive negative thing just much simpler to understand. Okay, so right in the middle we've got 0, right? So let's just say we've got 10 up here, we would have negative 10 down here, negative 5, and positive 5. Okay, so let's see, simplify the absolute value expressions. So remember that your absolute value is always going to be positive. These answers are going to be positive answers unless there's a negative in front of the absolute value bar. So to go from negative 8, which would be down here, you're just asking, what is that distance from negative 8 to 0? And from 0 down to this was 8 spaces, so that's just going to be 8. Easy. Absolute value of 9 is just 9. Absolute value of negative 2 3/4 is just 2 3/4. Here you're going to make that calculation first. So 12 minus 7 is 5, and the absolute value of 5 time it's different, because you want to look at what's inside the bars first and then think about the negative. So the absolute value of 5/3 is 5/3. And then after we've taken care of that, taken the bars away, then we're going to apply that negative to it. So that's the only time that an absolute value expression will be negative. Okay? So now let's try some of these, and we're going to put them in order from least to greatest. And just like we used to do with putting decimals and fractions in order, now that we've added in negatives and positives and absolute value, I want you to put them all in the same form. So much easier to deal with. Okay? Okay, so here we've got 3.6. We can write that as 3 6/10. I think I'm going to put everything into fractions because they're pretty easy fractions. The absolute value of -3/2. I know that answer is going to be positive, so that's going to be 3 2/10. So I already know this one's bigger than this one. 4 goes into 13 3 times with 1 left over, which is 1 1/4, right? Which is, we know, is 0.25. So now it's bigger than the 2/10, but smaller than this, the 6/10. And then we have 3/8, which is less than half, right? 4/8 would be half. So, okay, so think about what we've got here. So if you want to convert it into decimals, that's fine. So this one you would have 3.6, 3.2. We know a quarter is 3.25. Half of a quarter, so half of 200, we can make this 250, would be 125, and you have 3 of those, so that'd be 3.375. So now you just need to put them in order from least to greatest. So this one would be smallest, next smallest, and largest. Okay? So where you're going to put those, they're all going to be kind of squashed in here between these two, but this is the order they would be. So 3.2 would be about here, 3.25 really close next to it, 3.375, and then 3.6 out here. Okay? Alright, let's do this one real quick. So, -1, now we have to think about, now we're on the negative side. So I only want you to look here. And if you think about it, just ignore the negatives for a minute and think about what they would be if they were positive, right? Because it's the same thing, we're just going on the other side of 0. So let's say if they were positive, right? You've got 1, 4/3 is 1 1/3, so now we've got 1 is smaller than that. Or we could have this in decimals, 1.33, 1.2, and I don't know what square root of 7 is, so let's do square root of 7, and that gives us 2.64-ish, 2.64-ish, okay? But now the difference is, now when I put them down here, they're going the opposite direction. Negative, this is a big thing I'm going to teach you. Negative means opposite. So instead of graphing those points to the right of 0, we're just graphing those points to the left of 0. So when you're going smaller, you've got a point at 1. This is at 1. 1.2 would be right next to it. 1.33 would be right next to that. These are all negative, of course. And then 2.64 would be over here. So it's just on the other side of 0.